Welcome to the lecture. Today we are going to see the problems on misanalysis with dependent source. Here there are four different types of dependent source, that is current controlled current source, current controlled voltage source, voltage controlled current source, voltage controlled voltage source. So by using any of these sources we are going to solve the problem using mesh analysis. Now let us see the example for dependent source. Use mesh analysis to find the current I0 in the given circuit. Now, in this case, here you are having 3 loop circuit. So now, here the I0 is present here. So, the step 1 for the mesh analysis is, first we have to identify number of mesh. So, in this given circuit, we will have 3 meshes. That is, let I1 be the current in loop 1, let I2 be the current in loop 2, I3 be the current in loop 3. Now, for each loop, we have to apply the Kirchhoff's voltage law to write the equations. Now, for each loop, we are going to apply the KVL. Apply KVL to loop 1. So, before going to apply the KVL, we have to identify whether the given voltage source is voltage rise or voltage drop in each loop. Then, what type of source they have given. Either it may be voltage source or current source. So, now in this case, for loop 1, they have given with the voltage source. That voltage source and the assumed current direction both are in same direction. So, that it will be a voltage rise. So, that we are writing 24 equal to 10 into I1 minus I2. In this case, the 10 ohm resistor is connected in common between loop 1 and loop 2. So that we are writing 10 into I1 minus I2 plus 12 into I1 minus I3. Similarly, 12 ohm resistor connected common between the loop 1 and loop 3. Now, if you simplify that, we will get 10 I1 minus 10 I2 plus 12 I1 minus 12 I3. Now, if you simplify that, we will get 22 I1 minus 10 I2 minus 12 I3. So, if we rewrite this equation, we can write 22 I1 minus 10 I2 minus 12 I3 equal to 24. Take this as equation number 1. Now, similarly, apply KVL for loop 2. Apply KVL to loop 2. So, we have to check whether any voltage source connected in loop 2. So, in this case, there is no voltage source connected in loop 2, so that there is no voltage rise or voltage drop. So, 0 equal to 10 into I2 minus I1. Here we are taking second loop as a major loop, so that we are writing 10 into I2 minus I1 plus 24 I2 plus 4 into I2 minus I3. So now we can simplify that, minus 10 I1 plus 38 I2 minus 4 I3. So we can rewrite this equation, minus 10 I1 plus 38 I2 minus 4 I3 equal to 0. Take this as equation number 2. Now, similarly, we can apply the KVL to loop 3. Apply KVL to loop 3. So, again, we have to check whether any voltage source are connected in loop 3. Yes, in this case, here the voltage source is connected, that to dependent source. So, we have to check what type of dependent source it is. That is current controlled voltage source. So, in this case, the current controlled voltage source, that is I for I naught. The I naught is the value which depends on current through 10 ohm resistor. So that in this case you have to write the equation for I naught. I naught is which is the current flowing through the 10 ohm resistor. So that we can write the current through the 10 ohm is I1 minus I2. Okay. Now we have to apply the KVL for the loop 3. That is minus 4 I naught equal to 12 into I3 minus I1 plus 4 into I3 minus I2. Now we know the equation for I naught, that is I1 minus I2. We have to substitute that. Minus 4 into I1 minus I2 equal to minus 12 I1 minus 4 I3 plus 60, sorry, minus 4 I2 plus 16 I3. Now we have to simplify this equation. Minus 4 I1 plus 4 I2 equal to minus 12 I1 minus 4 I2 plus 16 I3. So we can rewrite this and combine the coefficients of I1 and I2. So minus 12 I1 minus 4 I2 plus 16 I3. That by taking the term minus 4 I1 plus 4 I2 to right hand side, it becomes plus 4 I1 minus 4 I2. We can simplify this equation. We can get minus 8 I1 minus 8 I2 plus 16 I3 equal to 0. Take this as equation number 3. Now, if you solve this equation 1, 2 and 3, either we can use Cramer's rule or we can solve this equation with the help of the calculator. Now, solve equation 1, 2 and 3. You can get the values for I1 is I1 equal to 2.25 amps. I2 equal to 0.75 amps. I3 equal to 1.5 amps. But in this case, in this problem, they are asking current through 10 ohm resistor. That is, find the current I naught. So, I naught is nothing but current through 10 ohm resistor. So, that you have to write. Find the current I naught. So, I naught is equal to I1 minus I2. So, we know that I1 value is 2.25, I2 value is 0.75. If we simplify that, we will get I naught is equal to 1.5 amps. Thank you.